In many films and science fiction novels, Titan, the main moon of Saturn, is presented as a world to be colonized, or as a base inhabited by strange beings, or as a colony inhabited by terrestrials in exile. But could Titan's conditions be suitable for hosting humans? Would it be possible to colonize this world? And why is Titan interesting from this point of view? In this video, we will try to answer these questions. Titan is the second largest moon in the solar system after Ganymede, one of the main Jupiter satellites, and is even larger than the planet Mercury. It has a diameter of about 5,150 kilometers, while the diameter of Mercury stands at just over 4,879 kilometers. Titan is the main satellite of Saturn and was discovered by the Dutch astronomer Christiaan Huygens with a refracting telescope of 57 millimeters in diameter and 310 millimeters in focal length, who called it in Latin Luna Saturni. It was the first natural satellite to be discovered after the Galilean satellites of Jupiter. The current name Titan was proposed by the astronomer John Herschel, son of the more famous William Herschel, in honor of the Titans of Greek mythology. Titan travels its orbit around Saturn in about 15 days at a distance of about 1,221,830 kilometers from the planet. This distance is equal to just over 3 times the average distance between Earth and the Moon. So if you left from Saturn traveling at the same speed as the Apollo lunar spaceships, to reach Titan you would take roughly 10 days. In short, a long journey, but after all still feasible for a holiday out of town, if you're already in the neighborhood of Saturn. But pay attention, leaving from Earth to Titan, the matter is very different. We remember that Saturn is located about 9 astronomical units from the Sun. An astronomical unit is defined as the average distance between Earth and the Sun, and is equal to about 150 million kilometers. So Saturn is 9 times farther from the Sun than the Earth, and this journey takes a few years. The NASA Cassini probe, named in honor of the Italian astronomer Giovanni Domenico Cassini, a great scholar of Saturn and its rings, was launched from Earth in 1997 and entered into orbit around Saturn only in 2004. So how do you go about taking a human crew there? Whatever form of propulsion you choose has pros and cons. For example, you could use rockets like the current ones, whose technology is already available and above all well tested and reliable. But the con is that you have to transport large quantities of fuel, and this translates into the need to build large tanks, which add a lot of weight to the ship. And if a spaceship is heavy, it is much more difficult to take off from Earth. An alternative could be to use a thermoelectric radioisotope generator, such as those of the Cassini spacecraft, based on the decay of radioactive isotopes. But here too a problem arises: how to protect astronauts from the radiation produced by such thrusters. Furthermore, unlike a robotic spacecraft like Cassini, a manned space mission has much more complex needs. For a very long period, in the case of Titan, 7 years, it is necessary to guarantee water, food, oxygen in the right quantities for survival. And this translates into the need to build a spaceship large enough to carry adequate supplies. However, there are at least 2 other major problems concerning interplanetary human spaceflight: radiation and the psychological aspect. As far as radiation is concerned, as long as a spaceship or space station is in a low orbit around the Earth, they are quite sheltered from cosmic rays and solar radiation because they are still located within the Earth's magnetosphere. But once you get out of the Earth's magnetosphere, it is believed that if absorbed in massive doses and for long periods, such as during an interplanetary journey, in the long run, cosmic rays and other radiations could cause the onset of more or less serious diseases. But to date, this aspect is not yet well clear. The other big question concerns the psychology of astronauts. Studying the behavior of astronauts aboard the International Space Station, it emerged that to admire our planet from the cupola, a window module with 7 portholes built entirely in Italy, is essential for their mental well-being, to feel somehow at home and to suffer less isolation from their friends and relatives during their long months in space. But what might be the astronauts' reaction while traveling in interplanetary space to reach Titan? On such a long journey, isolation is much more challenging, also because these hypothetical astronauts for years would not see any other person outside of their crew members. Moreover, the same communications with the Earth would be quite difficult. If you wanted to send a message to your loved ones from Titan, it would take about an hour and 10 or 15 minutes to arrive. And the same goes for the answer. To probe the psychological effects of long-duration space missions, terrestrial simulations of mission to Mars, such as Mars 500 or High Seas, Hawaii Space Exploration Analog and Simulation, have been carried out for several years now. A group of specially selected people live for several months or even a year in conditions of total isolation, in habitats in remote places to reproduce the conditions present on Mars, living exactly as a real astronaut would do. That is, they eat rehydrated food, send and receive messages with a delay of 20 minutes, the same as with the Red Planet. In the case of Titan, it would be more than an hour. They ration supplies and energy. They cannot have direct contact with the outside, and if they venture outside the habitat, they must wear a heavy spacesuit. Also, if any accidents happen, they need to be able to handle it on their own. To increase the sense of isolation, from Titan they would see the Earth only as a small blue dot, lost in space, and the same sun seen from that remote world would appear about 10 times smaller than how we see it from Earth. Titan has a synchronous rotation, that is its period of revolution. Time taken to make an orbit around Saturn is equal to its rotation period. How long it takes to make a rotation around its axis. But how long does a year on Titan last? That is, how long does it take Titan while orbiting Saturn to complete an orbit around the Sun? The answer is 29 years. In practice, 1 year on Saturn or Titan equals 29 Earth years. For example, a 58-year-old person on Earth on Saturn or Titan would only be 2 years old. Its acceleration of gravity is equal to about 1.35 meters per second squared. So on Titan, you would weigh only around 1/7 of your weight on Earth. But be careful, your mass, that is the amount of matter you are made of, remains the same. Because exactly what changes is your weight, because the gravity of the celestial body which you are on changes. The surface temperature of Titan is about 94 Kelvin, that is minus 179.15 degrees Celsius, therefore rather cold, given that a very small part of the light and solar radiation that we receive on Earth reaches Saturn, and therefore also Titan, about 1%. According to data collected by the Cassini spacecraft and the Huygens lander, it has been possible to verify that the internal structure of Titan is characterized by a rocky core surrounded by layers of ice in different crystalline forms. A layer of liquid water and ammonia was also detected around the core. Thanks to the data and the spectacular infrared images collected by the Cassini spacecraft and the Huygens module of the European Space Agency, which landed on the surface of Titan in January of 2005, it was possible to assess the presence of methane lakes and channels carved from the same methane on the surface of Titan. Some of these channels somewhat resemble the canyons found in some places on Earth, such as the Grand Canyon. But the most interesting thing about Titan is its atmosphere, which exerts a pressure at its surface of 1.6 bar, equal to about 1.5 times the Earth's atmospheric pressure at sea level. Titan is in fact the only satellite of the solar system surrounded by an atmosphere, made up of 95% nitrogen N2 and methane CH4 for about 5%, plus traces of other molecules based on carbon, nitrogen, and hydrogen. It is believed that these proportions are very similar to those of the chemical composition of the atmosphere of the early Earth, while the density of Titan's atmosphere is greater, 1.15 times, than that of the Earth. Moreover, the atmosphere of Titan is about 10 times thicker than Earth's. This implies that the sky brightness on Titan at midday through its very thick cloud layer could be very similar to the Earth's sky brightness 5 minutes after sunset. Measurements carried out by the spectrometers on board of Huygens and Cassini probes have also detected the presence of toluenes, organic macromolecules rich in nitrogen. It is thought that they are formed by the dissociation and ionization of methane, and in the case of discrete quantities, as in the case of Titan. also from the molecular nitrogen inside the celestial body or in its atmosphere by high-energy particles or solar radiation, producing ethane, ethene, acetylene, hydrogen cyanide, and other molecules. These small molecules combine with each other to form more complex molecules, such as aromatic compounds, benzene, and other organic molecules. These complex units tend to polymerize to form an aerosol of heavier molecules, which, in the case of Titan, in addition to settling on its surface, would also be responsible for the orange mist that envelops the entire satellite. Since this atmosphere is not breathable for humans, once on Titan it would be necessary to build plants capable of producing oxygen. But how to produce the necessary energy? Given the great distance from Earth, a human settlement should be completely self-sufficient. According to a study published in 2017 in the Journal of Astrobiology and Outreach, there may be several ways to produce energy on Titan. Geothermal. It plans to exploit Titan's residual internal heat, produced by the release of thermal energy by the nuclear decays of heavy elements present in the core and by tidal interactions due to the gravitational attraction of Saturn and other low Saturnian satellites. Unfortunately, this geothermal energy on Titan is very low. Wind. The problem is that near the surface of the satellite, these winds are very weak. While they are more intense at altitudes of the order of 3 kilometers and beyond, at 40 kilometers of altitude, winds below 20 kilometers per second. To exploit these winds, bound airships or balloons could be built, or even a special wind power plant, which could produce energy for hundreds of megawatts, more or less the amount consumed by the entire population of the USA. Solar. In theory, it is a viable hypothesis, but since Titan receives only 1/100th of the solar radiation compared to the Earth, to have a sufficient production of energy through solar panels, it would be necessary to cover a very large portion of the surface of Titan, more or less 10%, corresponding to 89% of the U.S. surface. Hydroelectric. A hydroelectric power station built in the vicinity of the Kraken Mare, the largest sea of methane on Titan, with a length of 1,100 kilometers and a width of about 500 kilometers, could produce energy for a period of time between 53,900 and 431,250 years terrestrial, roughly corresponding respectively to 1,840 and 14,740 years of Titan. Chemical. It plans to exploit the numerous hydrocarbons present on Titan, using them as reagents in various types of processes to produce thermal energy and oxygen. Nuclear. Already used to power some space missions, this method of producing energy is very interesting because it is potentially capable of producing energy for decades. Moreover, the radioactive elements could be extracted locally from the rocks, rich in silicates. So to conclude, in theory, the colonization of Titan could be possible, but certainly not in the short term, because a lot of scientific new research is needed to develop completely new technologies or improve existing ones.